where you get to listen to me for 15 minutes talking about getting rid of YAML. And, this is really a lot about kind of how we've adopted Dagger for the last month or two. We've been working quite a lot with Dagger in our very small, but I'll say very mighty platform team. I know I'm going to share kind of what we've been working on more on a high level. So depending on time, I might get into some of the really nitty gritty Dagger code itself. But most of this is more going to be high level on how we utilize Dagger and what Dagger has enabled us to do in terms of the platform that we can provide for our engineers with a new platform that we're building out. So, with that kind of disclaimer out of the way, if you do want to see Dagger specific Dagger code that we use that I don't have time to show off, just hit me up in Discord. This is currently not open source, but we are aiming to open source as much as possible. But there's a lot of work in progress. A lot of the code today is code I wrote 2 hours ago, so let's kind of hope that it works. Now, where I want to start off today is kind of tell you how we ended up in this place to begin with, which is this list of GitLab projects. It is very hard to read because I tried to fit it all in one slide. You don't have to read it. That's not the point. We have a lot of projects. Over the last 4 years or so, we've been kind of sort of moving towards microservices, but we started out with this naive idea of having each service being its own repository, and as services get smaller and we get more of them, we come to the same realization that everyone else in the world has already come to. If you write small microservices, you need a monorepo. And more importantly, where Dagger comes in is you need to invest in excellent platform tooling to enable engineers to be productive. So to recap, right, where we were at 2 months ago was having quite a large number of repositories. We realized that moving to a monorepo was a very natural path to go down, but we didn't have any kind of platform tooling to enable engineers to work efficiently. And so we started to think about what this experience should look like for our product engineers. At the same time, or around the same time, we were at a conference, Cube Huddle, in Scotland, where we met a couple platform engineers from Monzo, the UK bank, and also the organizer, David Flanagan, who we later ran a workshop with, who is also in the Dagger community. And we had some great chats with them, and we kind of discussed this concept of the paved road, right? So a paved road is obviously very smooth to drive on. There's no detours. It allows you to focus on the destination rather than the journey, right? If you want to go to Disneyland, you want to get on the highway so you can get onto the rides at Disneyland. You don't really care about the journey. And our engineers are the same way. They don't want to care about how things ship to production or how the images are built. They want to spend time writing application code. And so we want to provide this paved road for our engineers. But in doing that, there's a lot of dangers with this paved road, which is kind of what happens when you go off it, right? If you're driving down a real road, you go off that road, you end up on a smaller road. Now, it's not going to be a straight road. Maybe you can't go as fast, but you're not driving off the highway straight into the forest. Platform engineering tends to be a little bit different. In a lot of platform engineering, you build these manifest-based configuration files, and if engineers can't fit their work into a configuration file that you define, they're left on their own. So they either take the highway or they go off-road. So when, if we look at what a paved road looks like when platform teams build these, what I call manifest-based systems, right? In practice, that's usually YAML, some kind of configuration manifest that the engineers will fill out. In that world, small roads don't exist. It's really hard to escape the standard path, right? If you're following the organization standards, everything works well. And you might write some YAML that looks like this, maybe a bit bigger, to declare your service, right? You specify what language you're writing, maybe you specify some deployment configuration in there, but it's often a lot of YAML that developers have to deal with when I talk to people building platform tools. Now, when you want to try something new like Rust, you don't get to use a smaller road and figure out some parts yourself. Instead, you kind of go completely off-road. You have to learn how to get to the destination on your own. And you end up writing your own Docker file, you end up writing your own deployment scripts, you end up customizing your GitHub CI file. Those are all things that we don't really want application engineers to spend their time on, and they don't want to spend time on it either. And this is kind of where the code approach comes in, right? I believe code is a much more natural approach to providing this paved road because it lets you build a lot of useful abstractions that aren't just useful to product engineers, but also to you as a platform engineer, right? There's things that, when you write code, you write functions. And this is going to allow the product engineers to utilize your expertise without you having to directly support every use case. So if someone wants to start writing code in Rust, you don't suddenly have to go out and build tooling to support Rust. They can use the baseline tooling that you provide and build on top of that. So it allows us to still provide this highway for those that follow our standards, where they just declare one line and they get their code right. But it also enables product engineers to break out of part of the abstraction while they can keep the rest of it. And of course, they can go completely out of it and write their entirely own Dagger config here. Right here, we're overriding the test function and just using Rust instead. Because our platform team currently only supports Go. If our engineers want to use Rust, they could go and do this. So with this in mind, right, we kind of got into figuring out what did we want our developer platform to be like? Well, there's first a pretty obvious one. It should be easier to create new services than it was before. It was really painful. We wanted to make it easy. The next one was we wanted to get rid of YAML for our engineers, especially CI YAML, because it's the kind of thing that often results in 15 fix commits and feels like a lot of wasted time, right? Everyone's been there where you're fixing up an actions.yaml or GitLab.ci.yaml and you're pushing fix, maybe you're force pushing, you're disabling your protection and you're just force pushing until it works. That's the CI experience. And we wanted to avoid that for our engineers because it's a waste of time. And the third thing we wanted to do is enable experimentation without forcing engineers to own all of the build and release tooling for their service. So engineering teams should only need to own what is unique about their approach, right? If they move to Rust, but they are still shipping container images, they can still use our tooling for shipping those images into production. And so with that in mind, we started building something. And now it's when we get into the part that is make or break, because it's my first ever live demo. I've practiced it 0.8 times, and I wrote probably 2/3 of this code 2 hours ago. So let's see how we get along with it.
You're doing great, Leo.
Let's see. Hopefully the screen is still sharing. We've got a terminal.
Yep.
Hopefully that terminal is large enough. And in that case, I'm just going to go ahead. So to start off, we have our monorepo here called Omnia, and we have this internal tool called Ecto. So I'm not going to go too deep into this. There's one part of it that I want to show, but the thing I'm going to do now is just create a new service, and we're going to call it Dagger Demo. So just going to run that. It's going to write a bunch of manifests. This is fairly straightforward. It does a lot of stubbing. It runs a few commands. But I do want to touch on this part where we create the deployment configuration, because we actually use Dagger in our developer tool as well. This is not the main Dagger use case I'm going to show today, but it's a really cool use case that we want to dig into more in the future, because this is actually going to enable us to get rid of engineers needing to install other dependencies on their machines. And so all they will need, our end goal here is the only thing that engineers should need is Docker Desktop and whatever binaries our platform team ship. Right now, that is not the case. But for example, right, this stage where we create the deployment configuration, we actually use Dagger and the Pulumi image to initialize a new project without requiring engineers to have the Pulumi binary. So, got this project set up. Hopefully it's all initialized. See, there's a bunch of things going into the chat. Hopefully that's nothing I need to care about. So going into the code, we have this new service generated, and we get this CI directory. And actually, this completed faster than I thought, so I'm going to jump straight into this instead of where I intended. That is very, very tiny. Let's do some on-the-fly changes here to change my font size. Someone knows, where the font size is. Yes, there we go. Excellent. I'm so used to zooming in. There we go. Right. So this is the entire Dagger config that engineers need to use for us if all they want to do is use the bog standard setup for a Go service. They export the service pipeline. But of course, there's a few things that you can customize in here. Right now, this is all still a work in progress. So we don't actually have a test stage. We don't support running tests, which might be a fairly essential thing, but we do support it as a stage. So by having it all as code, it's actually fairly straightforward. Let's see if I can do this right as well. And I'm just going to type it as a constant just to get a little bit of help by the IDE. And do that. And then you can just declare the entire function here. And you get the override. And this is exactly as what I showed in the slide as well, right? So at this point, you're interfacing directly with Dagger, right? So you could call another function that our platform team has already written. Again, right now we don't have a test function, so maybe you just go and write it from scratch, right? So you'll just client container, from I guess Golang or Golang Alpha. And, you want to mount the directory, or you want to mount it into some path. And I'm not going to go in and write a bunch of Dagger code live because I don't know Dagger well enough. So instead, I'm going to console log it. Run a test. Sweet. And hopefully, I should now be able to run this. So if I now run, I'm going to use my wonderful history to find this. There we go. So we have our build Dagger index.ts. We say which command we want to run and which service we want to run it for. And if I did everything correctly, which I've never done before, there we go. It ran a test. So it ran the console log output. I have a lot of windows to keep track of. And yeah, that allows us to override it. If I remove this, it's going to use our default test stage, which here you can see returns an empty string. It does nothing. So run that again. We're going to see nothing because it does nothing. Now, the other part of this that I did want to show off is, and this is largely inspired by David Flanagan or Raw Code. So we did a workshop with him, and he's gotten quite into Dagger lately. And so I stole this idea from him. His part is all open source, so I will link that in the chat afterwards as well for those that are curious. But what we do here is we dynamically resolve this pipeline configuration file, and then we just call it with the client and a bunch of context, right? This is all, more or less TypeScript. There's no Dagger specific stuff in here, but this is what's going to allow us, this is the opportunity that's opened up by writing code instead of manifests, is that we can dynamically import these TypeScript files from our engineering teams in this case, ci/index.mts. And then we can actually import it and execute it on the fly. And again, this is just allowing our teams to customize their setup a little bit more than they could before. Now, I think I have a couple minutes, so I'm also going to dig into a bit of our actual pipeline just to, well, if I can find it. Let's see if I have it. There we go. So there's currently 3 different Dagger, I guess I'll call them Dagger pipelines that we run. And we run all this through GitLab CI, and I'll get to that in a moment as well. But so we run these all as separate stages that are each called by GitLab CI. So for build, we default to this Go build, and our release, we use Pulumi to generate Kubernetes manifests. Under the hood, this is all quite straightforward. Again, if you're curious, I'm happy to share it, but I think most of this is kind of just following the documentation. One thing that I think is really cool with what we do is because it's in a monorepo and we have a bunch of services that might have dependencies on each other, we actually read the Go mod file of the service, abstract or extract out the other service dependencies and build a list of them so that we can then mount all the dependencies into the build step, but without having to mount the entire monorepo, because as we scale this, mounting 100 or 300 services or 1,000 services into one build container is going to be really painful. So that's one of the really cool things that Dagger's kind of allowed us to do, is this partial mounting and dynamic mounting. So I think that's really cool. And then the rest is kind of standard. We use an SSH Unix mount to use Git and pull private dependencies, and then it's just go build. And again, I think most of this is actually documented fairly well, so I'm not going to go too deep into it beyond that. And I think I'm 17 minutes into it, so maybe I'm going to jump back to the recap. Sorry, I have a lot of different parts of this that I'd love to get into,
This is
especially
all
our GitLab
very
side. But time is a constraint, and I don't want to push it. And obviously, I also didn't prepare it, so I can pretend that time is the only reason. So right now, today, we automatically generate our GitLab CI YAML. We do that because of some limitations in Dagger, mainly around distributed processing. So if we had to run pipelines for 15 services at once, we want to be able to distribute that across multiple nodes. And so that is the reason that we still split the work up into multiple GitLab CI jobs. But because we don't want engineers to have to deal with it, we have a piece of regular Go software that just reads through our directories and generates the YAML for us, and then that calls Dagger. So we don't really use GitLab CI other than to actually call Dagger, and then Dagger does the real work. As I said, well, actually I say tests. We don't have a test function, as you just saw. So tests coming soon. But image builds and Kubernetes manifests currently do get generated with Dagger. This third point, I wrote that yesterday when we did not have customization. That object syntax is brand new from today. We haven't actually shipped it out, so no one else can use it. It only works on my machine. But that's what we're hoping to ship kind of, well, probably tomorrow or next week, this ability to override the configuration. And as I mentioned as well, we're partially using Dagger in our internal dev tool to reduce the number of dependencies that our developers need to install. So for example, we generate protobuf manifests using Buff, which is a great tool, but is one more thing that developers have to install for no good reason. And so we want to be utilizing Dagger more in that tooling as well, so that we can just kind of use Dagger, call the Buff Docker image, and shift all that work so that developers need fewer dependencies. Now, in terms of where we want to go, Well, this first one is exactly what I demoed, so that's what we're hopefully getting out to the teams next week, right? Is auto detecting this and letting developers customize. Secondly, again, expanding that use of Dagger and internal tooling, so reducing those dependency needs. And the third one, which I really pray that we can get to someday, and I've talked to the folks at Dagger about this, is someday I'd really love to not necessarily move away from GitLab CI entirely, but run a lot more entirely in Dagger so that we wouldn't need to have these predefined stages, but that developers could actually, if they wanted to add a brand new stage, that would be doable. Right now, that's a limitation of us kind of breaking it down into multiple GitLab stages. But I think there's a lot of kind of cool opportunities where we can extend this. I think there's actually things that we can already do inside Dagger to kind of try to simulate this, which I haven't fully explored yet, but it's something that I will be exploring. And overall, the point we're trying to get to is reduce any maintenance of YAML or YAML generation and kind of get as much of our configuration into code as possible. It's a lot easier when you can lint it, you can write tests, you can do all the things, and you can feel like a real developer instead of being on the platform team and just writing YAML for 1,000 lines a day.